Art to Part, Creating Winning Customer Products. My name is Cliff Medling. I'm going to be your host, and we're going to jump right in and get started as we have a lot to cover in just 22 minutes. First of all, using GoToWebinar, we suggest that you view this in full screen mode. Jordan, I think you may still be on pause.
Yep. Sorry about that.
No worries.
Yep.
Also, if you have any questions during the presentation, type them into the question field. We'll be sure to get to those after the 22 minutes is up. And we're going to be having some interactive poll questions for you. These are multiple choice questions which show up on your screen. And please submit those as soon as you can to keep us within our time frame. And we're going to share those results as well. And with that, I'm going to introduce our presenter today, Jordan Taddick. He is a Territory Technical Manager for Solidworks. He has a degree in mechanical engineering, but was originally planning on going to art school, so hence the Art to Part, and possibly pursue industrial design. Prior to SolidWorks, he has worked in manufacturing as an automation engineer for 6 years, and then as a SolidWorks reseller, 3D Vision, for a while before starting here at SolidWorks. So Jordan, it's all yours.
All right, thank you very much, Cliff. Yeah, so I'm a Territory Technical Manager, and like Cliff mentioned, I was originally considering going into industrial design. So this recent new edition of SolidWorks Industrial Design, the product, is actually a match made in heaven for me and allows me to finally use both sides of my brain with this job. So we're going to be covering the consumer product design process. And before I do, I just want to take a really quick poll question. So Cliff, if you could fire that up.
Yeah, so as you see on your screen, hopefully, do you design or manufacture consumer products? Just design, just manufacture, both, or neither at this point? And I'm going to give everybody a little bit of time here to respond. Looks like half of you have already responded, so I'll close the poll in a few more seconds here. All right, and share the results, and 48% do both, so looks like we're in the right spot. Back to you, Jordan.
All right, perfect. So if we were to take a look at the overall consumer product design cycle, we know from the last handful of years, SolidWorks has done an excellent job of taking what used to be serial processes that followed one after the other, and combine those with Engineering 4.0 into a single window interface and a parallel process that saves you all kinds of time and money. But more than that, more than just time and money, it actually increases your team's innovation because they're able to churn through more ideas more quickly, and they're able to test those wild ideas and validate them to see if they're actually on the right track. So what we're doing is we're applying that same scenario to the conceptual phase. What do you do before you actually fire up SolidWorks? And with the 3D Experience platform, we're creating complementary products to address these conceptual needs. Conceptual design is created for mechanical designs or mechanisms and machine design. And industrial design is created specifically for the consumer product process. So the example that we're going to be working through today in this short 22-minute webinar is designing a mouse from scratch. So that includes what normally would be probably a napkin sketch, all the way through a free-form model to the detailed design, and even consider some manufacturing capabilities and feasibility studies. So if we were to review the traditional industrial design process, it all starts with a 2D sketch, and this could be done on a piece of paper with pens and markers, or it could be done digitally on a pen digitizer tablet. Once the client or customer chooses the best design, then the industrial designer will go ahead and spend the time to create a 3D surface render. Now, the softwares that are being used for this portion of the process is not necessarily 3D CAD software for mechanical design. They could be piecing together surfaces that aren't necessarily stitched or knitted together. and not creating a watertight solid, which means the final portion of the process is actually making a product that can be mass-produced. And this is where an engineer would need to step in and make sure that things like draft angle are accounted for, and stitching all the surfaces together. And in a lot of cases, rather than trying to repair the 3D surface render, the engineer will just start with the design all over again from scratch. So the problem with this current process is that each one of these three segments are disconnected. We're using different design environments that don't communicate well with each other. And if we were to look at the overall design progress over time, we would see that the chart is pretty jagged. And what industrial design, SolidWorks industrial design, is targeting to do is eliminate these places on the chart where we need to start our work all over again. So we'd rather build on what we've previously accomplished. So one more poll question before I preview this process.
Yeah, so how are you currently capturing conceptual ideas for brand new products? On paper, like napkin sketches or detailed drawings, digitally, which could be 2D photo editing or sketching applications, 3D rendering, a non-CAD or 3D surfacing application, a combination of any of these above, or this doesn't really apply to you. So it looks like already half of you have voted. Give everybody a few more seconds to make their selection. Close the poll here and share the results. So a combination of the above, followed by on paper.
All right, great.
Hey, Jordan.
Thanks, Cliff. So what I want to do is I want to preview this conceptual design process for a consumer product inside of industrial design. And it starts by sketching naturally on a pen tablet. So it's just as like you were sketching on a napkin or a piece of paper, because we can control, with the pressure of our pen, the density of the lines that we're drawing, the thickness, and how dark they are as well. So it feels very natural, but the benefit of doing this in a CAD-like environment is the fact that we can perform CAD-like commands on it, mirror the geometry over, trim and extend entities. We can even hold down the modifier keys like Shift and Alt to switch between sketching arcs and lines. So in very short order, we can conceptualize a shape the same way we would naturally, but the benefit is that all of these sketches and the entities will be available to build upon for downstream features. So none of our work is going to be lost, and all of it's going to be reused when it comes to actually creating a 3D model. We can even turn on smoothing algorithms so that it will correct your sketching curves and lines to make them smoother than they might have actually been sketched in the first place. And we're doing this in a 3D environment, so it helps to communicate your design even more clearly with your prospective clients. Now, when it comes to creating the 3D shape, we're not doing so in a feature-based environment. We're doing so in a free-form environment. And what you're seeing on the screen right now is pretty much a virtual hunk of clay. And we're moving it in a very intuitive manner. We're grabbing and selecting these control vertices and dragging them around to resize this overall shape, again, just like a virtual hunk of clay. Now, the benefit of doing so is, number one, your changes are immediately visible on the screen. There's no delay or waiting for a feature to be calculated to be able to see how your modifications are going to affect the overall design or shape of the part. And we're not having to spend a lot of time learning how to use the software either. All you have to do, again, is window select these vertices, and you can either scale, translate, or rotate. And you don't have to only select vertices. You can grab faces and edges as well. So in this case, I'm selecting a handful of edges, and I'm actually rotating them to apply a nice little contour on the front portion of this mouse. So the other huge benefit of SolidWorks Industrial Design in this free-form modeling environment is the fact that every single change that we're making, the surface generation is ensuring that we are maintaining a G2 level of curvature continuity. And if you're an industrial designer that's on this webinar right now, you know exactly what I'm talking about, because curvature continuity across each surface is incredibly important for consumer products. It's what greatly influences not only how the part's going to feel in our hands, but also how the light is going to reflect off each one of the surfaces and ensure that we have an extremely professional and organic shape that is going to look good in any environment. So that's the process of creating the free-form shape. And obviously that was a little bit accelerated, but only by 3 times. So the overall design process for that really wouldn't take more than 10 minutes. So investigating that design progress over time, whereas before with the traditional process it was a pretty jagged chart, with industrial design, because we're able to reuse our sketches, because we're able to reuse that geometry, and because we're doing it all in a single environment, there's no loss of work, and we're able to streamline our design in a very efficient manner. So you might be wondering, if you're on the webinar right now and you're already familiar with SolidWorks, well, can I just create that with SolidWorks' surface modeling tools? And the answer is yes, you could have. But what you're going to be doing in SolidWorks is going to require a much higher level of detail. SolidWorks takes everything down to the 8th decimal place in accuracy and precision, and that's not necessarily needed or wanted in the conceptual design process. We want to limit our level of detail so that we can quickly iterate through changes faster than we could normally. So that's why SolidWorks Industrial Design is a perfect fit for generating this free-form feature. But to turn this shape into an actual product that could be manufactured, that's exactly where SolidWorks can be used to add the necessary features for this entire product. So I want to review some of those features, and whether you've never used SolidWorks before or you are already familiar with SolidWorks, you may or may not know about these features, so this could be a little tips and tricks section for you. Number one is the curvature combs, which helps us understand the curvature across each of the surfaces, and it will allow us to tweak them if we want to adjust the curvature. But again, SolidWorks Industrial Design is ensuring that we have G2 curvature continuity across all surfaces, so that's why you see those nice transitions in those curvature combs as they progress through the surfaces. Draft analysis is another quick, simple analysis tool to make sure that our part is actually manufacturable in a mold environment, like a plastic injection mold tool. And it will clearly highlight any face or portion of a face that does not meet our required draft angle. Same with an undercut analysis as well. Now, to turn this into an actual product, one of the first steps that we're going to need to do is shell this geometry out so that it is not just a solid chunk of material and it's hollow on the inside. And a good SolidWorks tip that a lot of people overlook is a check entity tool, which allows you to interrogate the entire solid model and find a minimum radius of curvature. Not only what the value is, but it'll even point that little green arrow at the precise location that it is occurring. So if I needed to make any adjustments there to increase the minimum level of, or minimum radius of curvature, I could do so. Now, as long as we keep our shell thickness less than that minimum radius of curvature, then we know that we're going to produce predictable results. SolidWorks has a parting line feature which automatically detects an appropriate parting line. On this particular component, it takes no time at all because it's a very predictable, easy to recognize parting line. But on other components that might have surfaces that are straddling both negative and positive draft, we can actually have the parting line tool split those surfaces appropriately as well. From the parting line, we can create a parting surface, which is generally used to create tooling to surround the geometry. But here we can invert the direction of that parting surface to actually use it to split the component in two. Now, Solidworks has an unbelievably convenient multi-body modeling environment where we can split a single part file into multiple bodies, essentially creating a static assembly. But we're doing so within the comfort of a single part file, so we don't need to worry about data management and so forth until we finalize the design and save each one of those bodies out as separate part files to apply different materials and part numbers and so forth. Now, Solidworks, again, has all kinds of features, not only Solidworks Premium and Professional, but every single one that I'm showing here on the left-hand side of the screen is available in Solidworks Standard. So it's feature-packed with a bunch of features that are going to optimize and automate your consumer product design. And the lift and groove feature is a perfect example. Rather than creating complex sweeps and trying to control the curving throughout that sweep, all I need to do is input my simple parameters into that dialog box that you see on the right-hand side of the screen. For creating ribs, we don't need to create extrusions and control end conditions and so forth. We can just draw out a grid. We don't even have to worry about the endpoints of that sketch, and SolidWorks will do the rest. It can even add draft during that process. Now, let's say we had to accommodate for a battery pack, and this battery pack might have been modeled in a separate component. We can actually insert a part into a SolidWorks part file to reference it to create downstream features from. We can locate that battery pack in an assembly mate-like environment to position it appropriately, and then we can use the indent tool to actually create a contour that will perfectly conform around that battery pack. So that's a very simple feature, again, to use to accommodate for other geometry. The snap hook and the groove are two associative features that will always be aligned to each other, again, allowing you to import or create general geometry from a basic and simple, easy-to-use property manager. And just like the snap hook, the mounting boss we can create as well. So repetitive geometry is no task at all for SolidWorks because we have the features to accommodate those needs. This is an interesting workflow in the case of, maybe we want to insert a little rubber insert on the side here for a grip. We can draw a 2D profile, project it onto a 3D contour, and split those faces as if we were scribing that surface with an X-Acto knife. What that allows me to do is use a thick and cut surfacing tool to cut normal to that contoured 3D surface and eventually create another surface and thicken it to create that rubber insert. Again, this is all being done within the single part but multi-body environment so that if any of this geometry changes, these rubber insert will update to those changes. Now, SolidWorks Professional and SolidWorks Premium include a package called SolidWorks Costing. And as you're designing, as a designer, it's very helpful to know, well, if I make this feature change, how is that going to affect my cost downstream? And what I mean by cost is the manufacturing cost. So SolidWorks Costing accounts for material, manufacturing processes. We actually can accommodate for plastic injection molding process, and you can choose between hot runner, cold runner, your lot size, your waste material percentage, and so forth. And SolidWorks is going to continually calculate the cost per part so that it's visible as you're making changes to the model. Finally, for manufacturing purposes, even as a designer, you might be concerned about is the product I'm making actually feasibly going to be able to be injection molded? And we have a SolidWorks package just for you to be able to test that feasibility. But for the manufacturers that answered that poll question, that you're also involved in the manufacturing process, we can do much more than that with SolidWorks plastics, and that is predict warpage, balance and optimize the manufacturing process in this family mold, making sure that they both have the exact same fill time, and plenty more options for you as well. So again, that overall design process, we took it from concept sketch to predicting the manufacturing process with these three simple products: SolidWorks Industrial Design, SolidWorks CAD, and SolidWorks Plastic. So in industrial design, we were able to capture our concepts, just sketching them like we would be on a napkin, and visualize in 3D with the free-form modeling as if we were modeling a hunk of clay. The SolidWorks allows us to prepare that shape for an actual manufacturable product, and SolidWorks Plastics allows us to analyze the feasibility and optimize the manufacturing process as well. So again, if you guys have any questions, please type them into the questions, but I'm just going to turn it over to Cliff.
Jordan, thanks a lot. That was a ton of great information in a short amount of time. I appreciate it. Just a couple more quick poll questions. Also, as Jordan mentioned, if you have other questions for us, there's quite a few questions that we'll answer live here as well. If you want to type those in now, that'd be great. I'm just going to wait and let this one roll for a little bit more. Actually, let's go ahead and take one question. I know there was a question about your original sketching. Jordan, did you do that with like a Wacom tablet or similar tablet, or was that hand drawn with the mouse?
Yeah, no, absolutely. I did that with a Wacom tablet, and I was able to not only use the Wacom tablet to sketch, but also use the pressure sensitivity as well to control, you know, the boldness of each one of those sketch lines.
Excellent. Just want to throw up one last poll question, and this is really, do you need any further information of us? A lot of you are SolidWorks users already, but I know Jordan went over a lot of this in a short amount of time. But if you want a live demo from one of our great SolidWorks resellers all over the world, click the second button here, and we'll be sure and set that up for you. Or if you're just looking for quote or pricing information about SolidWorks Industrial Design or SolidWorks or any other products you mentioned, plastics, select that one, and we'll be sure to get to that one. I'm going to leave this up a little bit while we answer some more questions. I also wanted to introduce Mike Sabacek, who's, as you can see, answering a lot of questions for us. He's an area technical manager as well. So there were some questions about integrating industrial design with SolidWorks. So maybe you could talk about that real quick, Jordan.
Yeah, absolutely. One of the things that I should point out is that with industrial design, it passes off that free-form shape into SolidWorks as imported geometry. But every single feature that we build onto that imported model gets registered in the SolidWorks feature tree history. Now, at any time, I could go back to industrial design, completely tweak the shape around, and replace that imported feature by relinking it to the updated industrial design model. What that will do is update that original imported model and reapply all the downstream features. And typically, those are updated with very little hassle and pretty much fully automatic. So the process of going back and forth between industrial design and SolidWorks is pretty seamless.
Yeah, we had several questions here. I know Mike's answered them about, you know, industrial design is not an add-in; it's an actual extra product, and it's not a desktop product as well. It's all online, cloud-based product. So
yeah, it actually does get installed locally, but when you're saving your components and such, it's part of the 3D experience, which is a cloud-based platform. So your file storage will be taking place online. And this is because it's a conceptual product, right? So we wanted to make that conceptual environment very easy to communicate with others, not only to generate geometry, save geometry, and manage the data, but also share that with others. And allowing it to be on the cloud allows others to collaborate without having to install any software, because most of those tools are just browser-based.
Right. Hey, a quick question people have asked about the recording. I think I failed to mention this earlier. We are recording this presentation,